Welcome to the deep dive. If you thought AI was just a fun little novelty that helps write emails or maybe summarize some articles, our stack of sources this week is going to radically change your perspective.
Hmm.
We are no longer talking about future possibilities. It feels like we are reading the manifesto of what is accelerating right now.
Yeah.
AI is moving from the research lab into the central pillar of global operations. And the big theme, the thing we keep coming back to today, is the agentic shift. AI moving from a tool to a teammate. Okay, let's unpack this.
It's the sheer volume, right?
Yeah.
The competitive intensity of it all. You see these staggering financial commitments, the geopolitical rivalries, the urgent regulatory responses.
Yeah.
It all signals that AI has crossed this threshold. It's not an add-on anymore. It's a core global system. So our mission today is to cut through all the noise, all the executive summaries, and really focus on the strategic reality. What does this intensity mean for you? For the autonomous systems you're going to be relying on, maybe even working alongside tomorrow?
And the foundation of this whole thing, this acceleration, it isn't intellectual, it's physical. The first thing that just leaps out from these documents is the unbelievable scale of the compute arms race. This is not being decided on paper. It's being decided with concrete and power grids.
Exactly. The investments are, they're not in the millions for startups anymore. We're talking billions for infrastructure.
Yeah.
Just look at the capacity growth. Alibaba's Zhangbai data center, Microsoft's Fairwater Atlanta facility. And then there's this incredible figure, AWS committing up to $50 billion
50 billion.
just for AI and supercomputing infrastructure, and that's just for the U.S. government sector. That lever of investment, it signals that the major players are bracing for a demand curve that it completely outstrips anything we have now.
So the core strategic fear seems to be if you don't build the infrastructure right now, you won't even have a place to run the next generation of models when they arrive.
That's precisely the panic.
Yeah.
And that build-out is global. And it's highly strategic. They're targeting areas where market penetration is just exploding.
Right, like the moves into India and the Middle East. I mean, OpenAI is negotiating with TCS for at least 500 megawatts of data center capacity in India. That is a massive electrical commitment.
It is. And it points directly to securing capacity where the user growth is exponential.
And it matters because the market is already shifting, isn't it?
It is. The sources show Gemini is dominating worldwide search queries in 2025. It's outpacing ChatGPT in high-growth regions like India.
So you have to be where the users are.
You have to. It forces this strategic push to secure capacity there, to capture or just defend your market share. And then the move into the Middle East, with AWS and NVIDIA partnering on an AI zone in Saudi Arabia.
Deploying up to 150,000 AI chips.
Yeah, that's pure geopolitical influence. It's about securing massive training runs. Compute really is the new oil.
And that competitive scoreboard is clearly terrifying the incumbents. Our sources are confirming that the moment Google dropped Gemini 3, OpenAI entered a code red phase. They're accelerating development of what we think is GPT 5.2 or maybe 5.5, codenamed Garlic.
Which confirms the theory, right? The gap between major model releases isn't years anymore. It's shrinking to just months.
Months.
And that urgency makes sense when you see players like Alibaba. Their Qwen app showed massive global growth, 149% month over month. This is a multipolar, incredibly intense contest.
Let's
The
see.
leaderboard changes every single quarter.
And we're seeing these investment signals just everywhere, reflecting the rivalry. You have Meta's really brilliant early GPU bets paying off hugely now that the metaverse pivot is well over.
And then you get these cultural moments like Cristiano Ronaldo investing in Perplexity.
Yeah.
Everyone is placing a bet.
But what's fascinating here is that the arms race isn't just about building the biggest model anymore.
No, it's about building the most efficient one. Because size means expense.
And expense means fragility.
Exactly.
So can you elaborate on that efficiency push? We saw Claude 4.5 Opus setting a new pace on AutoCode Bench v2, but the really exciting stuff seemed to be about cutting the operational costs.
Absolutely. Think of cost as a competitive barrier. If you can have your operational expenses, you can double your deployment or your training runs. That's what this new MIT adaptive scaling method promises. It cuts LLM computational costs by up to 50%.
50% without sacrificing performance.
That's the claim, and that is an incredible operational advantage.
But where is the money actually going inside the model? If they're cutting costs, what part are they optimizing?
This is where the technical insight from Token Power Bench comes in. Their analysis found that over 90% of a large language model's energy use It happens during the prefill and decode stages.
Okay, so for the listener who hasn't tracked the internals, can you just quickly explain prefill and decode?
Certainly. So prefill is basically the AI reading and processing your entire prompt. It's setting up the context, calculating the initial state.
Getting its head around the question.
Exactly. And then decode is the actual process of the AI generating the response, token by token, word by word. The shocking part is that most of the cost is in the setup, the reading, the initial calculation, all before the first meaningful word is even written.
Wow. So the strategic goal now is to make the model's reading comprehension and its internal scratchpad more efficient, not just speeding up the final output.
That's a good way to put it.
And that deep focus on efficiency in Part 1, it directly funds the ambition in Part 2, making the models truly smarter. We're moving beyond, simple text generation into this era of specialized reasoning.
This is the brain upgrade we've been waiting for. The real defining architectural shift right now is Google's Gemini 3 Deep Think mode. It's rolling out to Ultra users, and it significantly improves reasoning by forcing the model to explore multiple hypotheses in parallel.
For complex tasks like math and coding.
For exactly those things.
So it's not just guessing anymore, it's brainstorming. It's like turning the model into a small team of collaborators, and they check each other's work before giving the final answer.
Precisely. It's a confidence check that's built right into the architecture. And you can see the real-world impact. Usage patterns from our sources show a definitive shift. Reasoning models now account for most of the tokens being used on platforms like OpenRotor.
Which tells us users are trusting AI with harder, more analytical problems. They're not just asking for summaries anymore.
They're not. And beyond that pure logic, we're seeing huge leaps in multimodality.
The ability to fuse different data types together.
Yes, fusing text, images, other signals. It's key to real context. Meta and Cost introduced Moss mixture of states, specifically for better multimodal fusion. And in the creative space, Gemini 3 Pro is topping the SVG generation leaderboard. The quality of its vector graphics output is state-of-the-art.
We're also seeing these really specialized models designed not just for speed, but for scientific rigor.
That's right. Releases like Mistral 3 MoE are leading the open-source coding leaderboards, which is huge for developer productivity. But maybe more interesting for foundational science is Anthropic's progress on Core Bench.
What's that for?
It's designed to test models on scientific reproducibility tasks. It's an effort to train models that actually understand the scientific method and empirical validation, not just language patterns.
Okay, so if the model's getting smarter, that should mean it's more reliable, right? But the big challenge is still the hallucination problem, the smart, authoritative-sounding lie.
It is. And progress in reasoning has to be constantly checked against reliability. We are seeing some architectural solutions, like the Agentic Pre-trained Transformer, or APT, which specifically targets reducing hallucinations, but the data quality issue, that's arguably the bigger problem.
Right. We saw Yejin Choi's critique about sloppy synthetic data. If we're training these powerful models on mountains of machine-generated, potentially flawed data, aren't we just amplifying garbage?
That's the core concern. She correctly warns that certain reinforcement learning methods can actually degrade reasoning quality if the training signals are poor. The solution is moving away from that coarse feedback to better, more subtle training signals. The approach we see in QuietStar is a good example. It really highlights that the bottleneck for deep, reliable reasoning is now the quality, not the quantity, of the data and the fine-tuning process.
And all of this compute, all this reasoning, it leads us right to the most impactful shift this week, the agentic shift. Here's where it gets really interesting. AI is transitioning from a tool you talk to a functional, autonomous coworker you deploy. It's no longer about asking a question. It's about handing over a complex task.
This is where the theory hits the road, commercially. We are seeing the birth of a digital workforce.
Exactly. AWS has already debuted autonomous agents, Kiro, a security agent, DevOps agent. They're automating really complex parts of enterprise operations.
And in finance, Itaú Unibanco in Brazil, they've rolled out the Devon agent across their entire software development lifecycle.
So the agents are writing the code now, not just suggesting it.
Yes. And if you need any more proof that the industry sees these agents as permanent, monetizable employees, look at Microsoft. They're seriously considering subscription fees for AI agents within Microsoft 365, positioning them as digital coworkers that need their own licenses.
The pace in the public sector is just as astounding. At a recent DC summit, Google developed over 300 AI agents in a single day.
300.
In one day. Designed to address critical government challenges, emergency response, cybersecurity, you name it. That demonstrates true deployment maturity.
And what's really disruptive is how quickly this power is being democratized. You don't need a deep coding background to build one of these agents anymore.
We saw that with Google Workspace Studio. It lets anyone, a person in Gmail or Docs, create custom AI agents just using plain English.
And that democratization goes out to the web layer, too. WordPress's Telex AI tool lets non-technical users build interactive website features.
Like calculators or score locators?
Exactly. Complex things, all with natural language. This fundamentally changes who gets to build sophisticated digital products.
Now, shifting away from enterprise automation for a second, let's talk about the high-stakes, real-world payoff. Agentic AI is actively saving lives.
The impact in healthcare is profound. It's undeniable. The Brainomix 360-stroke AI tool, it's in over 70 NHS hospitals now. And it's doubling life-saving thrombectomy rates by accelerating clot detection.
Doubling them.
Seconds matter in stroke care, and this AI is shaving off crucial minutes. And similarly, Children's National Hospital unveiled an AI tool for fast, accurate pediatric TB detection from X-rays. These are life-altering productivity gains, not just numbers on a spreadsheet.
But agents are just software, and software fails. So what happens when these autonomous systems hit a brittle environment, a flaky API, a network glitch?
That's where the infrastructure that supports the agent has to mature. LangChain, which is central to building a lot of these systems, they acknowledge this. They added automatic retries and middleware specifically to help agents recover gracefully.
So the agent's intelligence is useless if it just quits at the first error.
It's totally useless. It needs resilience.
And on the consumer side, we see companies betting on that resilience. Pine just raised $25 million to advance an AI agent that negotiates your consumer bills and resolves service issues.
Right. And that's an agent that needs to be tough enough to handle long customer service calls and those tricky automated menus. But this incredible velocity, this deployment, it brings with it an immediate, urgent rise in risk.
Yeah.
If we connect this to the bigger picture, every single new capability is also a potential new vulnerability.
And the sources confirm that. The critical counterpoint to all this acceleration is the immediate and rising concern over security and governance frameworks that are just struggling to keep up.
Let's start with the hard security threats in engineering. Aikido Security found PromptPront. It's a critical vulnerability affecting AI-integrated GitHub and GitLab pipelines.
Okay, what does PromptPront actually mean for an engineering team? That sounds severe.
It is. It means an attacker can potentially leverage a compromised AI output inside the pipeline, maybe an AI helping with code review, and use it to leak sensitive secrets or manipulate the entire workflow.
So if your AI is talking to your deployment system, and AI can be poisoned, your whole system is compromised.
Your whole system. It's a massive new attack surface.
So how is the industry responding to this, to securing these agent-to-agent communications?
By creating new defense protocols. A cybersecurity startup, 7AI, got record funding specifically to develop AI security agents that monitor other AI agents. And crucially, Helmet Security raised $9 million to safeguard Model Context Protocol communications, MCP.
MCP is the new standard for how agents talk to each other.
It is. And securing that internal dialogue is now the priority. We're also seeing Anthropic launch Sconebench to find vulnerabilities in blockchain smart contracts. It shows that highly complex financial code is now a target for automated defense.
Beyond security breaches, we have to talk about the systemic ethical and social risks that come with these models.
Absolutely. The problem isn't just that models reflect our biases. They can generate novel, biased content at scale. Google's Nano Banana Pro image generator faced heavy criticism for repeatedly producing racially biased white savior imagery.
And when those tools are used for content creation at scale, say in news or humanitarian aid, that propagation of flawed output becomes a real crisis.
It does. And the political implications are immediate. They're quantifiable.
I saw the study you're referring to. It shows AI chatbots can measurably shift voter intent.
Measurably. And they found that the most persuasive models are often the ones most likely to spread subtle misinformation. This isn't a theoretical manipulation. It's a quantifiable impact on democratic processes.
And we're already seeing language from the U.S. Congress seeping into UK parliamentary speech through this prompt culture. It shows how easily ideas can be filtered and amplified.
Regulators and the courts are clearly stepping in. The EU launched antitrust probes into Meta's integration of AI on WhatsApp, fearing anti-competitive bundling.
And in that landmark legal case, a U.S. judge mandated OpenAI turn over up to 20 million anonymized ChatGPT logs to the New York Times for their copyright lawsuit.
That is highly significant. The courts are forcing transparency into the black box. They're demanding access to the underlying training data logs, which are often the smoking gun in these battles.
And that legal pressure, in turn, seems to be fueling transparency efforts inside the labs themselves. We saw OpenAI mention they're developing a confession system.
A system that trains models to self-report mistakes and questionable actions. It sounds futuristic, but it underscores the severe trust deficit.
Right. Data leaders worldwide still report major gaps in visibility into AI decision-making.
And if we're moving toward an agentic future, the ability of that agent to explain why it did something or just to admit it messed up, that is foundational to any kind of trust or accountability.
So what does this all mean?
It means the entire technological landscape is pivoting around two core facts. First, we've seen this unprecedented global investment in compute, and that's fueling smarter, more rigorous models like DeepThink and Claude 4.5 Opus. And second, that refined intelligence is being immediately translated into autonomous agents, deployed in virtually every sector, from code review to life-saving stroke care.
So the core takeaway for you listening is that the shift is now complete. AI has moved from merely answering questions to aggressively doing tasks. And this agentic future requires urgent attention to security and governance, things like monitoring for prompt hound attacks and securing MCP communications. They're clearly struggling to keep pace with the sheer velocity of deployment.
And we know AI can measurably shift voter intent. We know political language is crossing borders through these powerful prompt cultures. We've also uncovered new vulnerabilities in the pipelines themselves. So here's our final provocative thought for you to consider this week. Given the known risk of persuasive misinformation and the new complexity of these autonomous systems, how will you verify the source and the underlying intent of the most persuasive piece of AI-generated content you encounter in the next 7 days?